Alright, now that we have looked at some basic addition of polynomials, we're going to take things one step further and look at some applications of this skill. So we're going to have a word problem here, and in this course, just in general, some good advice is to go ahead and read through the word problem once, and then go through and back and look for any important information that you think is going to help you solve the problem. So in a given triangle, the largest side is twice the length of the smallest side. The other side, that is not the smallest or the largest, so that's going to be the middle side, is 2 units longer than the shortest side. We want to write an expression that represents the perimeter of the triangle, and we want to let x represent the length of the smallest side. So now that I've read that, I'm going to go back and look at some important information. So one thing I want to always figure out is, what am I being asked? We are told that we want to write an expression to determine the perimeter of a triangle. If you remember back to middle school, perimeter is going to be the distance around the outside of the shape, in this case a triangle. So what we're going to have to do is to add up all the sides of the given triangle. Now the problem is we don't really just have side lengths. We don't know that the one side is 2, the one side is 5. It just gives us a bunch of words to kind of describe the relationship. So a couple things I'm going to do to help us out with this problem is, first I'm going to draw a triangle. Anytime you're doing one of these geometry type problems, a really good strategy is to draw a triangle. Now it doesn't have to be a perfect triangle. Obviously mine will not be. That's why I teach math and not art. But you want to kind of have a clear small, medium, and large side. Alright, so I also am going to just draw off to the side kind of a little bit of a brainstorming place for where we can talk about this information. So we know we have a smallest side, we know we have a medium side, and we know we have a longest side. And it does give us a very important piece of information that we can use to help us out with this problem at the very end. It wants us to use x to represent the length of the smallest side. So what I'm going to do is I'm going to, over here where I had my little brainstorming session, where I have small, I'm just going to put an x. And anytime that we're talking about the smallest side, we're going to use x to represent that. I'm also going to go ahead and label our drawing with that. Our shortest side is labeled x. Now, going back to the word problem, it says in a given triangle, the largest side is twice the length of the smallest side. So twice means it's going to be double or 2 times as long. Now, we don't really have anything to represent the longest side, but it did give it to us in terms of the smallest side. Remember, we were told to use x for the smallest side. So twice the length of the smallest side would be 2 times the x that we're using for the smallest side. So I'm going to go ahead and label that on my drawing as well. And then that just leaves me with one more side that I need to figure out. So the other side, which we called the medium side, it kind of was a little bit more wordy in its explanation, is 2 units longer than the shortest side. So again, we're going to put this in terms of the shortest side. So our shortest side was x, and we need something that is 2 longer than that. So if you think about how you would make something longer, you're going to be adding to it. For example, if the small side was just 4, and we wanted it to be 2 longer, we would do 4 plus 2. We're going to do the same thing here with the x, but instead of having a number first, we're just going to use that x that represented the small side, and we're going to add the 2 longer that the medium side is compared to the smallest. So that gives us the final piece of the puzzle on our drawing. We now have a triangle that everything is labeled. You'll notice that these are all going to have some like terms in them as well. So the last step is we go back to what we were originally being asked for, which was the perimeter. And that is the sum of all the sides added together. So I'm going to take my smallest side. I'm going to add my middle side, or my medium side. And I'm going to add my longest side. And that just gives us one chain that's going to give us a total expression for the perimeter of this triangle. So if you think back to the last video, what I need to do is I need to look for my like terms. Those are terms that have the same variable and the same exponent. So in this case, I have an x, a plus 2x. They're all like terms. And then I have 1 plus 2 that's kind of all by itself. He doesn't have anybody to partner up with. So he's just all by himself. So I do need to combine the ones that are the same. So remember, if we just have a variable with no number in front of it, that's like having an invisible 1 there. So I'm going to do a 1x plus a 1x plus a 2x, which is going to give me 4x. And then I have my last part, the plus 2. It didn't have any other like terms to add with it. So it's just going to stay as a plus 2. And that is going to be the expression that represents the distance around this triangle that we drew. Alright, you guys have a U-try problem, give it a try. Make sure to check it on the webpage, make sure you have the right answer, and if you have any questions, let your teacher know and they'll be glad to help you out. Alright, we got one more video, see you guys there.